Today let's take up queues, which comes in the lesson linked list, stacks and queues, and I'll do the array implementation of the queues today. So let's take this queue as an array. Now here we have got two operations in this. One is insertion into the queue and the other one is deletion from the queue. Now before actually moving to the concept of queues, like how insertion and deletion will be done, the first thing that you should know here is that queue follows the concept of FIFO, which is first in first out. Now here it's like a normal queue basically. What happens in a normal queue when there are 10 persons standing in a queue? The person who is standing in front, in the first position in the queue is attended to first, and then the next person, like this. So the first person who comes is attended to, and then the next one, like that it goes on, right? So here in an array, if I take a normal array, because this is, supposing I say this is an array here, let's say now here in queues we should have two positions. One is front and the other one is rear, right? Front refers to the first position. So supposing I say this is front, right? This is front here, and in the beginning when the queue is empty, like, right, so here when the queue is empty, then basically front and rear, right, both are equal to 0. Front and rear both will be pointing to the same place, right? This one, this is rear, right? Now as you keep on inserting your elements into the queue, now let's say this is the first element, and I'll put some numbers here, or let's say let's put some character values here. This is A, right? Now I want to insert one more element here, that is C, right? So what happens is, now the front here is the same, whereas the rear will now get shifted to this second one. So basically what happens when you insert an element into the queue, into the array here, front will remain as it is, right? And rear will become, rear is equal to rear plus 1. So now when you add the second element, now rear shifts to this position here. This becomes your rear, right? Okay. When you add one more element into this, let's say I put one more element here, I say B, right? And I insert one more element, and here I insert one more element. Now front is here, but the position of rear has now changed. Keep on adding 1 to this. From here C it moved to B, then B to D, and finally it is now here. This is your rear, right? So in queues we need to have two positions, one front and one rear, right? Now let's look at the algorithm for insertion into a queue. The first thing we do here is we check if rear is equal to null. If rear is equal to null, what does that mean? Here I had said it is equal to 0. This is also equal to, when front and rear is equal to 0, what does that mean? This is the first position, right? Before that first position, we can keep them as null or -1, whatever, right? In that case the queue is empty, right? So here If rear is equal to null, that means you're going to insert the first position into the queue, that is rear is equal to front is equal to 0, right? And whatever you want to insert, that will go into the 0th element. Q0 is equal to item, like this, right? If it is not equal to null, if rear is not equal to null, that means there is already some element in the queue. So here we say else if rear is equal to n. N is the size of the array. So here I say if rear is equal to n minus 1, because the array is, supposing I say there are 10 elements in that array, so the subscripting is from 0 to 9. Array subscripting is from 0 to 9. So if rear is equal to n minus 1, that means the array is full, right? Then print Q full, no element can be inserted, right? If we have put one else if and then the final else, that means neither the queue is empty nor the queue is full, right? Okay, so you will come to this place now. So here you will write Q is the name of the array here, rear plus 1. So whatever is the position of rear, earlier whatever was the position of rear, to that you will add 1, and then we will insert the item, right? And once you do this, here we have to increase the value of rear permanently by 1. So this is rear is equal to rear plus 1, right? So this is the algorithm basically, and we have to check for these three conditions whenever we are going to insert into a queue, right? So the first one being, we have to check whether the queue is empty, that is rear is equal to null. If rear is equal to n minus 1, that means the queue is full. If neither of these conditions is true, then this else condition will come, wherein you are going to insert element into the queue and you are incrementing rear is equal to rear plus 1, right? So let's look at the coding for this program. Here let's see, I'll write the function prototype. Let's say insert queue, right? This is for insertion into the queue, and here you have to pass the integer array and the integer item that is to be inserted, right? And then a display function for displaying the array. So here basically we have to give the array and then two integer values, which is front and rear, right? Now we can take the array, that is, let's say int q, right? And you can give a size to this array, whatever size you want. You can take these as global variables. Front is equal to minus 1, that is the null part which we have looked at there, and rear is also is equal to minus 1, right? Since we have taken front and rear as integers, we are putting minus 1. Minus 1 means the queue is empty, right? Okay. Okay, now come to this main function. Now inside the main function, we take one value which is to be inserted, right? And then a variable result, right? That's a semicolon there. And char ch, that is for the loop, right? Char ch is equal to y. put the loop here, while choice is equal to capital Y or small y, both cases will come, right? See out, enter the item to be inserted, right? Now that item is to be put in this value, C in value, right? And then result is equal to insert Q, right? And here you will pass the array which we have taken, Q, and then the value to be inserted, that is taken into this variable, right? Okay. Now this is the function call here, insert Q. And if you look at this insert Q prototype here, this insert Q prototype is giving a integer return type, right? Okay. So whatever is being returned, that we will capture in this variable result. Now we will write the insert Q function. This is int insert Q, and here we got this int item, let's say, right? Okay, now the same algorithm that we had put there, now we are going to do that. Now here I'll write if rear is equal to size minus 1, the n minus 1 condition which we had put there. What does that mean? That means the queue is full, right? If rear is equal to size minus 1, here I am saying return minus 1, because this function, this is supposed to return an integer value, right? Okay. Okay. Now else if, now here we check if rear is equal to minus 1. This condition means the queue is empty, right? If the queue is empty, this is the first element that you are going to insert. So you will write front is equal to rear is equal to 0. So now we start with the queue, both front and rear are pointing to the 0. And now what is always the insertion is to be put in this rear, right? Q rear is equal to the item, right? Else, now here Q rear plus 1, or what you can do is, there are two ways of doing this. Either I say this first, Q rear is equal to rear plus 1, right? And then after that we write Q rear is equal to item. Fine. Now these are the three cases, and here once these conditions are over, then I say return 0. Now you look at this, there is only one case where return minus 1 is coming. When this return minus 1 is coming, this means the queue is full, we can't insert any more elements, right? In the other cases, that is the queue is empty or there is already some elements and we are inserting the next element, in that case it will return a 0. So these values, either a minus 1 or a 0, will now go into this result, right? So if result gets the value minus 1, that means the queue is full. If result gets the value 0, that means the insertion has been done, right? Okay. So now what do we check here? We say if result is equal to minus 1, right? If result equal to minus 1, we say cout. This is a case of overflow, right? Overflow, element cannot be inserted, like this, right? Ended. And after this you can give a exit 1, and then close the curly brackets, right? Okay, now we have to do this only for equal to -1. If it is 0, it is already inserted, so there is no need to check that, right? If it is -1, then you say it cannot be inserted and you exit, right? After that comes the displaying part, right? See out. Now here, okay, displaying the Q, right? Now the display function has to be called display, and here you have to pass the Q and then the front and the rear. Okay. Now this function, this will display the Q. So here basically I'll write down the function here itself. This is your function, void display int Q, int F, int R. Right? We have taken these variables, these Q, front and rear as global variables here, right? So their values will be reflected in all the functions. These are global variables, right? If you have taken them inside a particular function like main function, then the values will not be reflected because we are doing a passing by reference, passing by value. In that case, we will have to do a pass by reference. But here we have taken these as global variables, so the values get reflected in all the functions, right? Now here void display int Q, F and R, right? Here you say if, okay, now look at this, if front is equal to -1, front is equal to -1 means again it is, the Q is empty, right? For, now we are displaying this, for int I is equal to front, we start from front and we have to go till rear, so I less than rear, right? I plus plus. Here you will display this Cout Q and here I, right? That's it. Here actually I'll change this, 1 minute. It should be I less than equal to rear. If you put I less than rear, then you should put one more line after this, that will be Cout Q rear, but we'll put it like this, which is simpler to understand. I is equal to front, here I'll write I less than or equal to rear, right? I less than or equal to rear, I plus plus, like this. And then you print Cout Qi. This is the same. If you want, you can write I less than rear and print Qi and then come out of the loop and then write Cout Q rear, right? But this is a much simpler way. You just have to display the Q. So basically this will do that, right? If you want to give something like this, after displaying this, supposing I say I want like this, Cout, this one, and then I give some space, right? Do like this, right? Okay, so this is basically displaying the Q here. After displaying the Q, here this is the function call, it will display the Q, and then here we can write Cout want to insert more elements, right? And then the loop will continue, the while loop which we had put there, right? So that's it. Basically, this is how the queues work, insertion into the queue that we have looked at today, right? So basically what you have to understand here is this algorithm, and understand that whenever an element is inserted into a queue, the rear is always incremented by 1. There is no change to the front, the rear is incremented by 1. That's what we have to remember here, right? So I have shown you the whole program for this. These are the function prototypes here. We have taken the global variables, front, rear, and Q is also taken as a global variable, and the whole program has been done here, right? So with that, I come to the end of this session on queues. Next session we will take up deletion of queues as an array.